Hello again. We are moving on to our topic of sets and logic. We're going to shift to the logic part of that now, and we're going to talk about propositions. This is lesson 5.8, so here we go. Again, we need to define some key terms. Propositions are those statements that can be true or false. And the truth value of a proposition is whether it is true or false. Some propositions are indeterminate because they don't have the same value, the same truth value for everybody. All right, and so now let's look at some notation. Every proposition is labeled with a lowercase letter like P, Q, and R. Those are the ones we're going to see most often. So a proposition I could say is my eyes are brown. Another proposition I could say is 35 plus 7 equals 42. And another proposition I could say is X is an integer. Okay? And then the negation of P, if I say that not P, that's written using that symbol there in front of the name of the proposition. So that symbol means not, and so the whole thing would mean not P. Okay, so in the above example, not P would be my eyes are not brown. So basically the opposite of what the proposition says. So let's talk about negation and Venn diagrams. I have a universal set U, just like always. P would be the truth set of proposition P. So that would be all of the elements in U that would make proposition P true. Okay, so it contains all those X's that make statement P true. Okay, and that means P prime, everything outside of that circle but still in the universal set, would be the truth set for not P. So that's how those two things link together. Okay, so here's an example. I have the universal set of integers from 11 to 17 inclusive, and I want P to be the statement, it is a prime number. So in that green circle, I'm going to have all of the elements of U that are going to be true of that statement. They are going to be things that when I mention them and I say it is a prime number, that would be a true statement. And then P prime will be all of those things that create a false statement when I replace it with that number. So that's basically what I said. So P is going to be the set of numbers 11, 13, and 17 because all of those are prime numbers. And then P naught is the truth set for, or sorry, P prime is the truth set for not P. So that's just going to be the other numbers 12, 14, 15, and 16. So that's just kind of a little demonstration of how Venn diagrams and propositions kind of fit together. If you have any questions, please let me know, and I will see you tomorrow.